Hi, this is Professor Merrill Lichty. I'm going to go through a short example that hopefully will help you understand the importance of statistical significance. The example is based on an article entitled What Steph Curry's Free Throws Can Teach Investors. This is something that was published on the Wall Street Journal June 8th, 2015 by Ted Jenkins, and here is a link to it. You can go and check this out if you like. You may need to have access to the Wall Street Journal, and if you do, go and check it out, and that will help put this in better context. Hi, this is Professor Merrill Lichty. In this short video, we're going to go through an example that will help us understand the importance of statistical significance in making decisions. The example is based on an article called What Steph Curry's Free Throws Can Teach Investors. It was published in the Wall Street Journal June 8th, 2015, and was written by Ted Jenkins. Here's a link to it if you want to check it out. You might need to have access to the Wall Street Journal content, but if you do, go ahead and look at that, and that will help you get context for this example. If you didn't get a chance to subscribe to the Wall Street Journal yet, don't do it just for this article. I'll tell you what happens. 2014-2015, Steph Curry of the Golden State Warriors was the MVP, and somebody decided that it might be interesting to determine if he's better at shooting free throws when he wears his mouth guard versus when he doesn't. Now, if you've ever seen Steph Curry shoot free throws, he's always got his mouth guard. It's either sticking halfway out of his mouth or he just leaves it in. And so this author decided it would be interesting to examine this in further detail. So without the mouth guard, Curry hit 198 out of 214 for a percentage of 92.5. With the mouth guard in, he hit 110 out of 123 for a percentage of 89.4. So at first glance, it's easy to see that with the mouth guard out, he does better. In fact, there's 3.1 percentage points higher without the mouth guard. And the article states that this is a substantial increase in free throw accuracy. The author then goes on to look at analogies to looking to financial strategies, looking back at historical data and using that to make decisions. So for example, if you have Fund A and Fund B, and Fund A outperforms Fund B by 1%, wouldn't you choose Fund A? Based on that logic, the author suggests that Steph Curry should always shoot free throws without a mouth guard. The author of this article is making a pretty strong claim based on a sample data set. But we might ask the question, is the claim warranted? Or in other words, is there really enough evidence in this data to conclude that Steph Curry is going to make more free throws if he doesn't wear his mouth guard? Well, we're going to treat this as a hypothesis test, and we first of all need to describe the parameters that we're interested in. First one is pi 1, that's the proportion of made free throws without the mouth guard, and pi 2 would be the proportion of made free throws with the mouth guard. And we want to test the null hypothesis that there is no difference. Null means no difference, so we call that the null difference, or the null hypothesis, and we write it as pi 1 equals pi 2. We really don't have any evidence or reason to believe that pi 1 should be bigger than or less than pi 2, so our alternative hypothesis is going to be a two-tailed that just says the proportions are different. And we're going to use a significance level of 5%. We're going to use Minitab to do this calculation. So go to Stat, Basic Statistics, and then to Proportions, and you'll see this window pop up. And we want to use the Summarize Data option because our data has already been summarized. There are other options we could use if we had the actual data values, but we're going to put in for the first proportion 198 events and 214 trials, and for the second 110 events, and that's out of 123 trials. So I'm not going to click on options because I just went with the defaults, so you can look at that on your own if you like. Here are the results that we get from Minitab, and you'll see there's a summary of the data that we put in, including calculations of the sample proportions. There's the 92.5 and the 89.4. There's other stuff in here. The difference in the estimates, for example, is 0.0309, and there's a confidence interval, 95% confidence interval. And what we're going to look at is the p-value. So the p-value is 33%, and what does that tell us? If we compare that to the alpha level of 5%, that says do not reject the null hypothesis. And you can also see that based on the 95% confidence interval, because that interval contains the value of 0. So this means that we don't have statistically significant evidence to suggest that there's a difference between wearing a mouth guard and not wearing a mouth guard. And I'm not sure why you would think that someone's better at shooting a free throw with or without a mouth guard. There are very strange rituals that basketball players go through whenever they're going to shoot a free throw, so maybe that has something to do with it. But the evidence that we are seeing here does not support the claim that he's better at one versus the other. Let's look at this p-value in a little bit more depth. Remember, the p-value tells you the probability of seeing something more extreme than what you observed if the null hypothesis is in fact true. And here we have a p-value of 0.33, which means there's a 33% chance of getting a difference that's 3.1 or larger in the situation. So the difference that we observe probably is due just to chance or random variation, and not due to the fact that the alternative hypothesis is true, which means that he's better at shooting with or without his mouth guard. The author tries to make a point that tracking historical data and using that as a basis for decision making is a smart thing to do, especially when we're looking for events that are going to take place in the future. And that's true. That's a big part of statistics. However, the example that he uses here with Steph Curry's free throw shooting is not a very good one, and the reason is because the difference is not significant, or not statistically significant. In other words, whether he wears his mouthpiece or not does not make a difference in what percentage of free throws he makes. It's more likely that what we observed was due just to chance. However, this is a good example of what not to do. And unfortunately, it's very common for decision makers to base important decisions on observed differences that could simply be due to chance, as is done in this case.